Hi everyone. In this video, we're going to be solving an equation that can be written in quadratic form. So sometimes you are given a very complicated looking equation that actually has some pretty nice properties to it that will allow you to go ahead and solve it quite simply. So I have a couple examples here I want to look at, and I want to discuss a specific technique that we can use if you're given an equation that happens to be set up fairly nicely, or you're given an equation that you are able to reduce to something that looks fairly nice. So, in these two situations, and anything that you're going to be doing in homework right now, it will already be given to you in some kind of a nice form. Okay. Only we might later in the class get to the point where we can simplify an equation to this point. But for this class, most of what you're going to be doing, it will be already given to you roughly in this form. You'll only have minimal manipulation to get into this form, if any at all. Okay, so let's take a look at this first one. Here we have x squared minus 17 squared minus 16 times x squared minus 17. And then we have that plus 64 is equal to 0. Okay, now I think it might be fair to say that your first temptation would be to go ahead, or your first thought would be to go, tempted to go ahead and FOIL out x squared minus 17 and then distribute the negative 16 and then see if you can solve it that way. But the problem there is you're going to end up with a degree 4 polynomial. And unless it simplifies to something very nice, we don't have a particularly good method for solving degree 4 polynomials. But there is something that's really nice here about this, and that is that you might notice that x squared minus 17 shows up twice in two different sets of parentheses here, okay? So you have x squared minus 17 here and here, okay? So we can do something that I like to call a variable substitution, or we can call it a U substitution. I use the letter U for this. Other people use different letters, just as long as it's a different variable than the variable you're given. So here, just track with me on this one. Let's say, let's just go ahead and let U be equal to x squared minus 17. Okay, so if we let U be equal to x squared minus 17, this equation becomes, this whole equation up here will become U squared minus 16U plus 64 equals 0. Okay, now this looks a lot easier to solve, right? This looks much easier to solve. So here we have something that we should be able to solve using techniques that we've already been given. So let's go ahead and do that. So we have U squared minus 16U plus 64. We want to find two numbers that multiply together to give us 64 and add together to give us negative 16. Here I'm thinking negative 8 and negative 8. Okay, so this is actually going to be U minus 8 times U minus 8 is equal to 0. Okay, so we actually would have, let's just go ahead and set this equal to 0. We have U minus 8 equals 0. So if U minus 8 is 0, that means this whole equation is 0. So for whatever the value of U is, that would make this 0, that would be what we set U equal to. So here we could solve for U. And we have U is equal to 8. So if U is equal to 8, then this whole equation is equal to 0. If you plug it in here or here, either one of these would be equal to 0. So U is equal to 8. But we know that U is equal to x squared minus 17. So in reality, this is x squared minus 17 is equal to 8. So let's go ahead and add 17 to both sides. And here we have then that x squared is equal to 25. And now what we can do is we can take the square root of both sides, and we get that x is equal to plus or minus 5. So we know that x equals 5 and x equals negative 5 are both valid solutions for this equation. And you can double check this by plugging this in to the initial equation, okay? So really all we're doing is we're substituting U for x squared minus 17, solving the equation for U, and then plugging x squared minus 17 back in for U once we've solved the equation, and then we can find our solutions. Let's take a look at another example. Here we have x to the fourth minus 17x squared is equal to negative 16. So before we do anything, let's go ahead and move this 16 over and set this whole thing equal to 0. So this will become x to the fourth minus 17x squared plus 16 is equal to 0. Okay. Here, again, we don't have any good techniques for dealing with degree 4 polynomials directly. So let's kind of hit this indirectly. And let's go ahead and let u be equal to x squared. If u is equal to x squared, then this equation will become u squared minus 17u plus 16 is equal to 0. And this is because this equation can be written as x squared squared minus 17x squared plus 16. And if we said u is equal to x squared, then we can write this as u squared minus 17u plus 16 is equal to 0. And again, we should be able to solve this one using techniques we already know. So let's see if we can find two numbers that multiply together to give us 16 and add together to give us negative 17. So here I'm thinking negative 16 and negative 1. So we can write this as u minus 16 times u minus 1. Okay? So these two numbers multiply together to give us positive 16. Negative 16 times negative 1 is positive 16. Negative 16 plus a negative 1 is negative 17. So that looks right. Okay? So we would set each of these equal to 0. So we'd have u minus 16 equals 0. We can add 16 to both sides, and we get u equals 16. Or we get u minus 1 equals 0. And we get that u equals 1. So u equals 16 or u equals 1. But remember, we said u was equal to x squared. So really, this is x squared equals 16, or x squared equals 1. Okay? Here we can just take the square root of both sides, and we get x is equal to plus or minus 4. And then here we can take the square root of both sides, and we'll get x is equal to plus or minus 1. So our actual final solution should have 4 possible solutions. So we have x is equal to 4, negative 4, 1, or negative 1. All 4 of these are valid solutions.